Good day everyone. Today I will be demonstrating how to draw a wedge-shaped follower and the shaft, as well as the cam profile of the displacement graph. We will start by drawing our displacement graph after we read the question. The question we will be doing is on the PowerPoint slide. I will start by drawing our displacement graph. The instruction says it has to be 8 millimeters for every 30 degrees. So I will start by drawing a long horizontal construction line over my page because I want to draw my displacement graph on this side of my paper. So we will start by taking our compass and open it up to the length of 8 millimeters. By doing this, we can ensure that all our intersections are of equal length. Let's choose our starting point, which would be 0 degrees. I'm gonna make it around here. There we go. Next, I will be dividing this construction line into 12 equal parts, each being 8 millimeters, to find the correct degrees of each. After finding our 12 intersections, draw a vertical line through each of those intersections. Next, we need to label these intersections. We are going to start at 0 degrees and count in 30s. 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. With that done, we can now place the movement on our displacement graph. The first one is saying over the first 60 degrees, the follower rises 31 millimeters. That means we need to, over our first 60 degrees, the height we need is 31. So we will open our compass, place it on 0 and open it up until 31. After that, trace the first 60, which is here, and make an intersection on that mark, and then connect the 0 and our intersection, and that would be the first part of our displacement graph, a uniform rise of 31 millimeters. After that, the follower is then at rest for 90 degrees. So once again, 1, 2, 3, that'd be 90 degrees in total. And in rest is just a horizontal line like that. Next is over the next 60 degrees, the follower rises a further 31 millimeters. So once again, over the next 60, so it's 1, 2, so it'll be here, but rises another 31, means it has to go 31 upwards. So let's extend this like that. Then we use our compass again at 31. There we go, make an intersection and then connect the 2 points. After that, the next thing we need to do is then the follower rests for another 60. So once again, 1, 2, so that's be 60 degrees in total. Sorry if my head's in the way. There we are. We have another one is the final one. The follower then returns to its original position of the final 90. So just make sure we drew it correctly. We need 90 degrees left on our displacement graph. So it's 1, 2, 3, that's 90. So just connect this to the bottom and we have arrived at where we started from. Now that our displacement graph is basically finished, let's just label it really quickly. So it's displacement graph. And you always have to add the scale as well. Our scale in this example is 8 millimeters equals 30 degrees. And now we're officially done with our displacement graph. Now we need to focus on our camshaft and the follower itself. The measurements for that is also found on the PowerPoint slide. I have the question in front of me, so I'll just quickly draw it according to those measurements. Here we are. I completed the follower and camshaft according to the measurements provided on the PowerPoint slide. Next, we need to number the 12 equal intersections I made through our camshaft, and for that we need to look at the rotation. Now the rotation is clockwise. That means we need to number anti-clockwise. You always need to draw this little arrow to indicate, okay, that is the direction it is going to rotate. So since we need to number in the opposite direction, 0 starts above our follower and then we go anti-clockwise. So 30, 60, 90, 120, 50, 180, 210, 240, 270, 300, 330, and then finally 360 back at 0. Now that we have completed that, we need to project all the intersections on the vertical line and our motion to our follower horizontally. So let's do that real quickly and let's name them as we go. Sorry for my head. You project them onto the center line of your follower. I like to keep things simple and name them to make it easier when we need to find the correct points on our 12 intersections through our shaft. I'm quickly going to project all points to my follower before I continue and name each of them like that. With that done, we are going to use our compass to draw arcs onto the correct line through our shaft. Now, just remember before we move on that the point of our follower is the exact same height as our displacement graph. You see it in exactly the same horizontal line. So let's start with projecting these points on our shaft we found from our displacement graph. So 30, we draw an arc to 30, make the intersection, and then we repeat this process for all the intersections we made. This one goes to 150 because we include 60, 90, 120, and 150. Next is 180. There we go. 180. Then we have 210. Now this is just a personal preference, but once I reach the halfway point, I just switch so that the lines don't confuse me. So we have 120. That includes 210, 240, and 270. Next would be 300. 300. and finally 330, since 360 is back at the very edge of our follower. There we are. And now that we have our intersections, I like to just make a small dot to make it easier to connect everything. Just a small dot like that. Now you can clearly see where our cam profile is. Therefore, all we now need to do now is connect all these points using a flex curve or even freehand. If you don't have one, I'll be using freehand. I'm quickly going to do that. Here we are, our complete cam profile. All that's left to do is just using our set squares and not color, but draw diagonal lines on our camshaft. Then we are done with this demonstration. Make sure you added all labeling you had to, and that is basically just your displacement graph and its scale underneath. And that's it. Thank you for listening. Have a great day.